Now let me just run a simple code snippet so that you can understand the working of MRS and MSR instructions. Okay, there are no errors, so I can go ahead with debugging the code. Okay, so the very first instruction I have is I have used a move instruction to load some random values into register. In this particular line I'm performing subtraction and I'm updating the CPSR. Initially it's just all zeros in the conditional flags. I want to see some values there. That's why I'm performing subtraction and updating the CPSR. So what should happen here? Same values, if you subtract, result is 0. So obviously Z flag is set as 1, and because any borrow is not generated, no borrow because it's same value, first value smaller than the second value, then borrow is generated. Here any borrow is not generated, so carry will be set as 1. Okay, let's see that happening. So now I have some CPSR content 6, all zeros, D and 3. Okay, now I will start using my instructions. Okay, you can start using it from the first step only, but conditional flags would all be 0 except for mode bits, everything else would be 0, just so that you can easily understand the difference. I've just added some extra instructions here. So my instruction here is MRS. So what should happen? CPSR register content should be copied to whatever register is specified here. So my register is R3 and my current value of CPSR is 6, all zeros and D3. So what should happen when I execute this? The same value, that is nothing but 6, all zeros and D3 should be updated in the register R3. So that is done. So my first task is complete. Next what I want to do is I want to perform MSR. Okay, what will this do? This will move the content of the register into your status register. Okay, and what this does, what does MRS do? It will copy the content of status register into the register you specify. Okay, so this is more like a read operation. Fine, we are reading the content of CPSR, while the next instruction here performs write. We are modifying the content of the CPSR or SPSR. Okay, so here before that I'm loading a big 32-bit value into R3. It's a pseudo instruction as we already discussed in the previous sessions. If you notice here, initial mode is actually supervisor mode, and that is something you should always know. Whenever I start executing any code in Keil, it always starts with supervisor mode itself. Okay, that is because one thing, when you reset the very first mode the ARM enters is supervisor mode. One more thing, user mode offers very little amount of resources. Okay, in order to execute complex instructions you should always prefer supervisor mode. The reason I'm specifying this now is because when you modify the control bits of CPSR, mode change will happen. That is, ARM mode changes from supervisor to some other mode as specified by my register content. Okay, so now let me just go back here. MSR SPSR underscore C. So it means change the control bits. Okay, the control field is the last 8-bit. So only that should get modified with what value? With the value 12. So let's see that happening. You can see the value has changed. Next, I want to modify only the flag field. What is it? The first 8-bit. That is the most significant byte. Let's see that happening. Yes. Okay, so that is also updated. Now I want to update the status and extension. Where are those? That will be these 4 bytes. Okay, let's see that getting updated with the value CDEF. Okay, so you can see entire SPSR is now updated, the content of R3. Okay, see here step by step I modified the content. Now I want to modify the entire content of CPSR with the content of R3. So you can see me writing CXSF. This particular register content will now modify the entire 32 bits of CPSR. Okay, but now if you notice, as soon as this instruction is executed, there is a jump from supervisor mode to interrupt mode. The reason is last 5-bit, it is 12 here. How will you write 12 in binary? It is nothing but 0001 0010. Okay, so this 5-bit actually represents the mode, and this particular data, okay, represents the IRQ mode. Okay, this mode change or modifying the content of the processor mode bits is only possible in case of privileged mode. You can't do that in non-privileged mode such as the user mode. Okay, so for now we will just continue here. So this task is done, and this is one more example of using an immediate value, okay, in order to modify the content of CPSR. As you can see here, I'm expecting all contents to get modified. Let's see that happening. Yes, and now if you notice, okay, the mode in which the ARM is currently working is actually system mode. So you can see it here, okay, because 1F is nothing but the processor mode bits used to represent the system mode. Okay, if you see here, I have forced the ARM to work in user mode, but what difference you will notice here is when I try to load this particular content into register R3, okay, and then execute these instructions to update the SPSR and CPSR, you can see that user mode cannot modify the content of SPSR. It can only modify the conditional flags of CPSR, but it cannot modify the content of any other field. That is, whether it's control, status, or extension, it cannot modify it. It can only update the conditional flag of CPSR, because of which you can only see that the very first 8 bits are modified, even if I have specified that all 32 bits should be modified. Okay, so that is something you should know about these instructions. If you want it to work perfectly and update all the contents, ARM should be in one of the privileged mode. In this particular non-privileged mode, it will only update the conditional flags. And now when I'm trying to read the content of CPSR into register R3, you can see that I can read the content of CPSR into the register R3 even if we are in the user mode. So those are few things that you have to know in case of MSR and MRS.